Hello there, welcome to this video. This is 9-3 and we are going to integrate some trigonometric functions. In this video, it's very important to have down your derivatives of trig functions and kind of the link between those two functions, because in this video we're going to be integrating, aka anti-differentiating, right? So we're going to be going back and forth. Okay, so I'm going to split this lesson into two videos. This video will specifically focus on some foundational trig integration, and the second video we'll look at calculating some area underneath the curve. All right, so here are the antiderivative rules based upon the derivative rules. Okay, so the main kind of function that you can remember is that if I'm going to integrate cosine, well, what's the antiderivative? Well, in order to get cosine, I have to take the derivative of sine, right? So the antiderivative of cosine is sine, and then the same thing for sine. The antiderivative for sine of x dx is cosine of x. Now, a good important kind of thing to remember, anytime you're going to get cosine or cosecant or cotangent, you're going to end up getting a negative. So when we integrate and our result is a cotangent, a cosecant, or a cotangent, we're going to have to drop in a negative. Okay, so that's just one kind of memorization trick that you can utilize. Additionally, too, again, you can notice, right, that these are directly tied to the derivatives, and that makes sense. Okay, so let's go ahead. We have a couple more rules which I don't think are conducive to memorization, but kind of how they are derived is helpful. Okay, so like, what's the integral of tangent of x, and what's the integral of cotangent of x? Well, what we're going to go ahead and do is we're going to rewrite these using our quotient identity, right? That tan of x is equal to sine of x over cosine of x dx. Okay, and now what I want you to see is that the hook for cosine of x, right? Like, what's the derivative of cosine of x? Well, that is negative sine of x. Okay, so if I go ahead and I rewrite this as the integral of 1 over cosine of x times, okay, times, I'm going to include out here my sine of x, okay, dx, and I also need a negative, so I'm going to drop in my negative 1 and then a negative out front. Well, okay, there is my hook, right? So I can integrate this as an integral of 1 over u, for example, right? Which gives us the natural log of the absolute value of cosine of x plus c. And we have a negative out front on that one. Okay, so there you go. Kind of easy. All right, number 2, cotangent of x. Okay, using the same idea here, I'm going to use my quotient identity that this is cosine of x over sine of x dx. Okay, and again, right, if I'm just looking at this, look at the denominator. Can I account for anything else with the derivative of my denominator? And the derivative of sine of x is cosine of x. Okay, so I can go ahead and again, I can rewrite this as the integral of 1 over sine of x times cosine of x dx, right? And then here is our hook that goes away. And this would be the natural log of the absolute value. I knew it was going to happen again. It always happens in like pairs. I don't think it doesn't like me zooming in that close. Okay, natural log absolute value of sine of x plus c. And there you have it. Now, in your notes, it says, hey, you should be able to memorize these. I don't know if those are conducive to memorization, but I think it is very possible to take the antiderivative of them using your quotient identities. Okay, so what we're going to go ahead and do is we're going to utilize the formulas here on this page and do some integration. All right, and these are considered kind of foundational, and hopefully you'll get pretty good at them with practice. Okay. All right, so we're going to go ahead and integrate negative 3 x dx. Okay, and for this example. Okay, note that the integral of sine is cosine, right? But with a negative, because anytime I'm going to get cosine, I have a negative. So negative 3, okay, negative cosine x plus c. And if I want to go ahead and just clean this up, this is 3 cosine of x plus c. And there you have it. Isn't that easy? Yeah, very easy. Okay, number 4. On number 4, notice I have a function on the inside of my trig identity, or my trigonometric function. Okay, so what that means is I have to account for, again, a hook. Okay, so my hook here, well, what's the derivative of pi t? Well, that would just be the constant, pi. Okay, so I have the integral of cosine of pi t. I need my hook, so this is a constant. I can just go ahead and introduce this. So I'll multiply by pi dt, right? And since I introduced it, I have to balance it. And now we are ready to go ahead and integrate. Okay, so this is going to be 1 over pi. Now the integral of cosine is sine of pi t plus c. And we're done. All right, next one. Same idea here. I am going to go ahead and look at the inside of my trig function, secant squared of y cubed. And lo and behold, the derivative of y cubed is 3y squared. Right? So notice I do have the y squared accounted for. I can go ahead and rewrite this to be the integral of secant squared y cubed. Okay, and then I'll go ahead and introduce a 3 with the y squared, and since I introduced 3, I have to balance it. So I have 1/3, okay, the integral of secant squared. Well, how do I get secant squared from a derivative? Well, that's from taking the derivative of tangent, right? So therefore, the antiderivative of secant squared is tangent. Tangent of y cubed plus c. Ta-da! Isn't this easy? Super easy. Okay, number 6. Number 6, notice again, we do have a function on the inside. So I have a hook, which is 2, and I'm going to go ahead and rewrite this. So some of you guys are looking at this, you're like, oh my gosh, what the heck is this? This one is actually very, very simple. Again, if you memorize your antiderivatives, your derivatives, and also too, if you memorize your antiderivatives. So I'm going to introduce a 2, right? There's my hook, and I'll balance it with a 1/2, okay? And the antiderivative of secant tangent is secant, right? So what's the derivative of secant? Secant tangent. Okay, so therefore the antiderivative of secant tangent is just secant. Secant of 2x plus 1 plus c. And there you have it. Okay, number 7. Number 7, couple of ways that you can do this, okay? So the first way I'm going to go ahead and show you is by splitting this. Now, if I look at the denominator right, I don't know how to take the antiderivative of sine squared. I don't really have that connection. So one method that you can do is I can go ahead and I can rewrite this as 1 over sine of 5x times cosine of 5x over sine of 5x, okay, and lo and behold, right, using our reciprocal identities and quotient identities, this is cosecant of 5x and cotangent of 5x dx. Okay, so I do have a hook of 5. So I'm going to go ahead and introduce that. Okay, so the integral of cosecant 5x, cotangent 5x times 5 dx, and I'm going to have to balance it with a 1/5. Okay, and how do I get cosecant cotangent? Well, that is the derivative of cosecant. Okay, so I have 1/5. Okay, and anytime you're going to get a cosecant, you're going to have to introduce a negative. Cosecant of 5x plus c. Okay, and there is your answer. Right, and that is the direct antiderivative here. Okay, so we just use that identity. All right, there is another way that you can go ahead and do this. The other way would be to go ahead and rewrite this. To rewrite this as the integral of sine to the negative second 5x cosine x dx, and then your hook, right, is what's the derivative of sine squared. Okay, so you could go ahead and do it that way, right, and that would be cosine of x and then times the 5, and you could get the same exact answer here. All right, last one, and the last one is pretty easy. Here I have the integral of secant squared theta over tan theta d theta, and again, now that I have this function written like this, look at the denominators and ask yourself, okay, like what is the derivative of the denominator? And that would be secant squared theta. Hey, don't I have that already accounted for in my numerator? Yes. Okay, so I'm going to go ahead and rewrite this as 1 over tan theta times secant squared theta d theta. Right, and then here's your hook that goes away. So this would be the natural log of the absolute value of tan theta plus c. And there you are. That's your answer. All right, pretty straightforward. So there are some basic trig integration that you can go ahead and utilize. Oh, I forgot my 5 down here. 5x. Okay, so basic trig integration, go ahead, remember the formulas, work with those and the antiderivatives just to store those in your brain. All right, catch you next time on the next video. Peace.